So now let's take a look here at example number 2, and I want you to actually go ahead and see if you can answer parts A through E here. Go ahead, quickly pause the video and see if you can answer these questions trying to find the most general antiderivative. Remember that you're going to be thinking about what could I take the derivative of that would generate each of these individual results. So thinking about your derivative rules is going to be very, very important. So go ahead, pause the video, try this out, and then when you unpause, you'll be able to see me work through each of these solutions. Okay, so hopefully you were able to work through these and you felt pretty confident doing so. Let's go ahead and talk about each of them. My first part here, my capital F of x function could very, very easily just be my tangent function plus c, because the derivative of my tangent creates secant squared. For part B, this is again one of those derivative rules that's the hardest to remember, but it could just be 2 to the power of x. The derivative of 2 to the power x is always 2 to the x natural log 2. This comes from the derivative rule of that the derivative of number to the power x was always number to the power x natural log of the number. Over here, my capital F of x could just be equal to the sine of x plus c. Derivative of sine makes cosine. Part D is actually a fairly simple one. I do have to make sure I'm a little bit careful here. Sometimes I'll get some students that will write natural log of 1 plus x squared. And even remember to put in the absolute value bars. But unfortunately, even if you put the plus c on this, it will not be correct. Because notice that the derivative of this would actually require that we do 1 over this value, but then multiply because of the chain rule. We'd have to multiply by a 2x. So I can't actually use this here. Instead, there's something even better. I can actually see that this is an exact derivative rule for my inverse tangent function. And finally here on part E, I'm going to have a negative cosecant of x. Remember that the derivative of a regular cosecant would be negative cosecant cotangent. So by having this negative here, I'm going to catch the negative that comes out of this derivative and leave me with something positive. Of course, to make it as general as possible, don't forget plus c. So hopefully you can see again here that all I'm really doing to find antiderivatives is I'm thinking about that big list of derivative rules that we actually generated back in chapter 3, and I'm pulling on those. I'm just thinking about, if I'm given the answer, kind of like what was the original question.